In this video, we're going to talk about inverse functions. What is an inverse function? Well, an inverse function is a function in which we have a reflection across the line y is equal to x. So you see here on the right-hand side, in gray, we have the line y is equal to x. This is the line where all the x coordinates is equal to the y coordinates. So you have your typical coordinate like 1, 1, 0, 0. These are the coordinates that are on the line y is equal to x. And the reflection that you can see is the function itself. If you fold the line y is equal to x, you should be able to get the inverse function. Now, the inverse function, we have the notation for it is the exponent -1. Now, it's very important that we remember that this exponent -1 does not mean that the inverse function is equal to 1 over the function. This -1 is simply a notation use for inverse functions. So it's not the same thing as 1 over the function. Another important thing to know, oh, that's denoted here. Another important thing to know is that the domain of a function is the same as the range of the inverse function. In a similar way, the range of our function is the same as the domain of the inverse function. And the reason why this is true is because at the end of the day, when you have an inverse function, you're replacing the x's by y's and the y's by x. So you're flipping them around, so it makes sense to flip around the domain and range. And then another important thing that we're going to be using to answer some of our questions is when you're asked to find the inverse of 10, so the way that it's denoted here, we can write this as an equivalent way using the function. So here, the 10, which represents the x in the inverse function, is actually the y in our function. So we're expressing it using a function. It gets easier for us to solve some of the questions we're going to have. In order to find the inverse function, we're going to need to follow some 3 steps. The first one is we're going to be swapping the x and y values. Then we're going to be rearranging the equation so that we have y isolated on one side. And then we're going to use the proper inverse notation to write down our final function. Let's do this example together. In this example, we want to find the inverse function of f of x is equal to 4x minus 5. So this function can be written as y is equal to 4x minus 5. Our first step is going to be to swap the x and y's. So we get x is equal to 4y minus 5. Our second step is to rearrange so that y is all on one side. In order to do that, I'm going to be adding 5 on both sides to get rid of it on the right-hand side. I'm going to have x plus 5 is equal to 4y. And then in order to have just y on one side, I divide both sides by 4. So I'm going to get x plus 5 divided by 4 is equal to y. My third step is to write it using the proper notation. So the y is going to become the inverse function is equal to x plus 5 divided by 4. You can keep it written as follows, or you can write it as x divided by 4 plus 5 divided by 4. Both are correct. Now let's do another more IB style question. We have the perimeter of a given square P. I'm going to highlight some important information here. So we have perimeter, which is P, can be represented by the function P of A is equal to 4 times the square root of A, where A is bigger than or equal to 0. A is the area of our square. The graph of P is shown where we have a restricted domain. Write down the value of P of 25. P of 25 means I need to look at my scale, and I notice that for the scale, I have 1, 2, 3, 4, 5 sections that represent 10. So each of these sections are going up by 2. So 25 is going to be here. And P of 25, that means we're looking for the y value at 25, and that would be 20. Next question. The range of P of A is 0 is bigger than or equal to P of A and smaller than or equal to n. Hence, write down the value of n. The range is all the y values. So we're going from 0 all the way to the last y value here. And this would represent the range of our function. So we can clearly see that this value of n is our highest y value, which would be 20. So what is the value of n? The value of n is 20. On the axes above, draw the graph of the inverse function. In order to draw the graph of an inverse function, the very first thing you need to do is to draw the graph. Draw y is equal to x. So y is equal to x is a line where you have x and y's are the same. So all of these coordinates, 0, 0, 10, 10, or even 20, 20, are going to be coordinates on this line. So with the ruler, you're going to draw a dotted line representing these coordinates. Your second step, all the coordinates that are on this line from the function are going to be part of the inverse function as well. So 0, 0 is on this line, and this coordinate here is also on the line, which seems to be 16, 16. So this coordinate 16, 16 is going to also be the same for the inverse function. So your second step is going to be that any coordinate that is on the line y is equal to x, and also the function are also going to be coordinates of the inverse function. And then the last step is if you notice that you have coordinates of the function. So for example, we have this coordinate here, which was 25, 20. Well, we're going to write that coordinate on the inverse function by switching the x and the y. So the coordinate becomes 20 and 25. So this coordinate 20, 25 is going to be on the inverse function. And our final step is just to connect all these points together so that it mirrors our function as best as possible. So I'm going to connect these two together and then connect to the top. And our last question. In context of this question, explain the meaning of P inverse of 8 is equal to 4. In context means we're going to need to use the variables in our question. So in our situation, we're going to need to use the word perimeter and the word area. Now let's talk about what the inverse of P is equal to 4 means. Well, I can write this equivalently using the function notation by switching the x and y, and it becomes P of 4 is equal to 8. Now this is easier for us to use because we now know that when the area is 4, the x value, well, our perimeter is going to be 8. And since they want it in context, we're going to write them a little sentence. And it's going to go something like this. The area of the square is 4 when the perimeter is 8.